Okay, so now we're actually going to solve the problem. F of x is x square root of x plus 1. Where is this function increasing? The answer is wherever f prime of x is positive. So how do we answer this? Well, we work it out. We first find f prime of x. That's product rule, the derivative of x times the square root of x plus 1 plus x times the derivative of x plus 1. Here and here. Derivative of x is 1, so we have the square root of x plus 1. The derivative of the square root of x plus 1, and you can work that out, is simply 1 over 2 times the square root of x plus 1. Now there's a chain rule involved, like you could have du dx where u is the square root of u, df du equal square root of u, and where u equals x plus 1. The derivative of u du dx would just be 1 because u is the function x plus 1, so you would simply have this. And again, work out the details. I'm not going to go into an explanation of that except to allude to it. Okay, so when is that greater than 0? Well, we just set that expression for the derivative greater than 0. Now, what do we do when we have something that looks like this? We multiply by the common denominator. Since there's just one denominator, that's easy. So we multiply every term by 2 square root of x plus 1. This term by 2 square root of x plus 1, and this term by 2 square root of x plus 1. And we get what? Square root of x plus 1 times the square root of x plus 1 is x plus 1, and then that's multiplied by 2. And then here, the 2 square root of x plus 1 divides out. We're just left with x. So we have 2 times x plus 1 plus x is greater than 0. And there's little cause for joy there because that's real easy to solve. We end up with 3x plus 2 greater than 0, and x is greater than negative 2/3. So that's where the function is increasing. Now also, where's the function decreasing? Well, it's decreasing when f prime of x is less than 0. And we run through all the same process. Of course, we already have the derivative, so we just set the derivative less than 0 and solve for x. We get x is less than negative 2/3. So on a big graph where negative 1 is here, negative 2/3 would be here. The value of our function is 0. So we're going to try to graph the function. We know that it's increasing to the right of negative 2/3. And decreasing to the left of negative 2/3. I'm not sure I said the negative in there last time, but it's negative 2/3. Okay, increasing to the right, decreasing to the left. What else can we say about the graph of the function now? Well, it's x times the square root of x plus 1. You have the 0 property of multiplication, that when two things are multiplied and you end up with 0, at least one of them has to be 0. So, well, they're not going to both be 0 for the same value of x. This is 0, of course, this being x. It's 0 when x equals 0. And the square root of x plus 1 is 0 when x equals negative 1. So we have the points negative 1, 0, and 0, 0 on the graph. And I'm going to label that. Okay, so negative 1, 0 is on the graph, 0, 0 is on the graph, again because when x is 0, f of x is 0. When x is negative 1, f of x is 0. And those are the only values that will give you a 0. Okay, well, let's look at the graph now in this small region. So we're kind of blowing this small region up, and so here's a small region. We blow it up, and we have it over here. Of course, I've got the graph drawn in here, but what do we know? We know that the graph goes through negative 1, 0, and 0, 0, and we know that its derivative is, well, we know that the function is decreasing to the left of negative 2/3 and increasing to the right of negative 2/3. So we can say, okay, well, function's decreasing here and increasing here, decreasing here and increasing here. So we got to start here and we got to go downward, but we've got to get around to where we're increasing once we pass this point. So we're going to expect to have to come down here and level off for an instant and then come back up. I'll also comment that the slope of the tangent line is 0 when x equals negative 2/3. So the slope of the tangent line is 0 at the x equals negative 2/3 point. So f prime of x is 0 at that point, and that point is a point, a minimum point for the function. Okay, at least a local minimum, and we'll talk more about what that means in the near future. Making a summary statement, f prime of x is less than 0 if x is less than negative 2/3. Now, less than negative 2/3 means we're to the left of the negative 2/3 point and we're decreasing. And f prime of x is greater than 0 if x is greater than 2/3. So to the right of negative 2/3, the function is increasing. Also, f prime of negative 2/3 equals 0. And from that, it follows that we have a function that's decreasing up to the point where it levels off and increasing beyond that, meaning that we have a relative minimum. Now, just a quick extra comment at the end. We can show that, well, in the first place, this function isn't defined for x less than negative 1 because you can't do the square root of x plus 1. If x is less than negative 1, you would have a square root of a negative. You would not get a real number, so the graph would not have meaning. Beyond x equals 0, the function continues to increase. Now, whether it continues to increase faster and faster, or increases maybe faster and then maybe slower and then maybe sometimes faster, we don't know, but we could figure that out by taking the second derivative, the derivative of the derivative, which would mean we'd have to take the derivative of this and then test that to see whether it was where it's positive, where it's negative, and so forth. Now, we're not going to do that, and you don't have to understand that right now, but you've seen higher derivatives in the preceding chapter, so you understand that we could take another derivative of this, and that derivative would be the rate of change of the derivative. And we could use that as an aid in getting even a better picture of the graph of the function beyond this point. So, using the fact that these 2 points are on the graph, functions decreasing here, increasing here, we get this picture of the graph. Add one more thing. If we want to plug x equals negative 2/3 in up here, we get what? Negative 2/3 times the square root of 1/3, which would be negative 2 times the square root of 3. And we can say that this low point here has coordinates negative 2/3, negative 2 over the square root of 3, and it actually would be better written negative 2 square root of 3 over 3, but it rounds off to something like negative 1.2. I believe that's probably correct to 2 significant figures, and that would be the coordinates of this low point. So we can tell a lot about the graph by analyzing its derivative and its zeros in this case.